I'd like you to imagine that our boss came up to us and said, hey, you know what? We'd like to make available to the internet one of our DMZ servers. How do we do that? Well, my friend, in this nugget, we are going to discuss how that's possible by using network address translation and security policy rules, and then we'll demonstrate it and verify that it's working. Let's begin. All right, my friend, here's our game plan. We've got this interface 1/3 that's associated with the DMZ zone on the Palo Alto firewall, and we're directly connected to the 10.2.2 subnet. We've also got a server, or we will have a server here in a moment, that we want to make available. It's got HTTP services, and we want it to be accessible by people like Lois out here on the internet. So there's a couple of things that we need to have. Actually, about 3 things we need to have in place for that to work. Number 1, we need to have a server. And its bare necessities would include an IP address. Let's go ahead and give it the IP address of 10.2.2.1 just for simplicity. And this device, the server, would also need a default gateway. And I've got a question for you. Based on our topology right here, what would be the perfect default gateway for this server, server 1, to use to get off of its local network? And if you said, Keith, the only possible default gateway on this topology is .250, which is the 1/3 interface on the Palo Alto itself. And that would be absolutely correct. So we need to have an IP address. We're going to use .1, a default gateway of 10.2.2.250, and it needs to have some type of web services running. The other thing I wanted to mention is that this DMZ network, this 10.2.2 network, is in our lab that is represented by VMnet2 in VMware Workstation. So if we're going to create a virtual machine or put a server on VMnet2, that puts it on the correct network. Besides having a web server running on the Palo Alto, we need to have network address translation so that we have some reachable address that is reachable out here to get to that server. And to do that, we're going to use static NAT. And in static NAT, let's use this as our plan. The address over here of server 1 is 10.2.2.1. And again, we're imagining that this 192.168.1 address space is globally reachable. And in that light, let's use a globally reachable address of 192.168.1. Let's use 251. So the outside interface of the firewall is using .250, and we'll use .251 for the globally reachable address of server 1 on the outside. So we'll set up the static NAT, and then the second thing we'll do is set up a security policy that says, please allow traffic that is sourced on the outside trying to go to that server to be allowed if it's HTTP, which is TCP port 80. So if we are going to recap what we're about to do, we have 3 things that we're going to do. Number 1, put a server on our DMZ on that VMnet2 network. Number 2, create a network address translation. And number 3, create a service policy rule that gives the permissions for that initial flow of traffic to come from the internet to that server. So our first order of business is to create a web server that we can place on that 10.2.2 network. Now there's lots of options for doing this. There's some small distributions of Linux. Windows servers often have HTTP services that can be enabled. We could use that. But I think for me in this lab environment, it's probably going to be the simplest and easiest to just use a router, a Cisco router, in GNS3. So I'm going to create a new project, and let's call this web server. And we'll click on OK. And in this GNS3 project, we're going to go ahead and we're going to create a cloud. So we'll drag out a cloud over on our topology, and we're going to right click on that cloud. We're going to select configure from the drop down, and we're going to configure that cloud to represent VMnet2, which you and I know represents that little network of 10.2.2 where we want our DMZ server. So we'll select that, click on add, and then click on OK. So now this cloud has one network interface which represents that 10.2.2 network. Next, let's go ahead and bring out a switch. And it's just a little generic GNS3 switch, just basic layer 2 connectivity. And we'll also bring out a router. So I have a 7200 series and a 3700 series router that I've got configured inside of GNS3. And if you need a quick primer on the basics of getting GNS3 up and running and setting up the iOS, please check out our GNS3 1.x fundamentals course. At least the first couple of videos, and that'll get you up and running very, very quickly. And then we'll connect these together. I'll use the connector tool. We'll go from R1's FA00 over to the switch, and from the switch over to the cloud, which represents the 10.2.2 subnet. I'll turn off the connector tool and I'll click on Go, and that will start the topology. In this case, R1 is now powering up. To get a console to R1, we'll simply right click. From the drop down, we'll select Console, and that brings up a console to R1. So if we look just for a moment at our topology, and I click on the labeling tool here, it's FA00 on R1. So the little trick I'm going to play is I'm going to have R1 with its FA00 interface. I'm just going to enable HTTP services on it. I'm going to give this interface an IP address and a default gateway that points out to 10.2.2.250. That'll be its default gateway. We'll give it the IP address of .1, and that will be our web server. Now, I totally get that not everybody has some familiarity with Cisco IOS commands to configure a router, and that's why I'm going to go ahead and put this as part of our Nugget Lab files, the commands right here that we could use to configure this router with its FA00 interface as the web server. So let me give you a quick overview of what these do, and then you can just copy and paste them in if you want to. So config T takes us into configuration mode on a Cisco router. This sets up a username and a password. The password is nugget !23. This enables HTTP services. This says go ahead and authenticate using this username in the local running config. This tells the router to go into interface configuration mode for FA00. This brings it up. This gives it the IP address that exits interface configuration mode. That sets the default route. And the N takes us all the way out of configuration mode completely. And the WR tells it to save the config. Also, if you're brand new to setting up GNS3, I found this resource as well that might be useful to you as well. And I've also included that in this document, which is part of the Nugget Lab files. So what we'll do is we'll simply take the enable all the way down to the right and copy that. We'll go to our command line interface on the router and we'll just paste it in. And in PuTTY, a right click does an automatic paste. If your terminal emulator is a little bit different, you might have to right click and then select paste. Either way, it's now configured. So basically what that means is our web server itself is ready to go on this 10.2.2 subnet, and it has the IP address of .1. Next, let's set up our network address translation on the Palo Alto, and we'll set up the security policy to allow HTTP in to that server. So here at the graphical user interface on our Palo Alto, we're going to go to the Policies tab up here, and we're going to set up our network address translation rule first. So over on the left, we're going to select NAT. Here's our existing PAT policy. We want to add an additional static NAT for the benefit of users trying to access the DMZ server. So we'll click on Add. And this is a little bit interesting because what we're going to be doing is we're going to be identifying a network address translation, but we're doing it from the perspective of the DMZ server itself. So if we take a look at our topology just for a moment, we're setting this network address translation up as if we're doing it for server 1, which indeed we are. And we're going to say if traffic is going into, for example, this interface, which is part of the DMZ, and if that traffic is going out of the outside interface, which would be the path between, for example, an outside user and the server, then we're going to specify change the source address of 10.2.2.1 to 192.168.1.251. And in the NAT configuration, there's a little teeny checkbox that says, do you want to enable this translation bidirectionally? So even though we're setting up the translation for the server as it goes out to the internet, if we click that checkbox, that translation will also work for individuals who are trying to go this way to get to that server IP address based on its globally routable IP address of .251. So we'll call this server 1 static NAT. And again, this is created as if from the perspective of the server itself going out to internet resources. So the original packet is going to be traffic, for example, from the DMZ server going out. So we have to think of where would the original packet from this DMZ server be coming from. And the source zone is going to be the DMZ zone. And the destination zone would be the outside. And as traffic goes to the outside, the destination interface would be Ethernet 1/1. If we take a look at our drawing for a moment, I just want to confirm the interfaces here. So sure enough, there's our one and only interface, 1/1. That's a member of the outside zone. That would be the egress interface as that traffic goes out to those users like Lois. And regarding that packet that would be going from the server out to the internet, the source address, we're going to go ahead and click on Add. And we don't have an object that represents that 10.2.21, that local IP address that's really configured on that server. So what we could do here is we could actually create one. We can simply click on this link to create a new address object. Let's do that right now. And let's call this server 1. I'm going to call it local IP to represent on the DMZ what it really has configured for itself on the box itself. And its IP address is 10.2.2. And it is 1. So no mask implies that's the actual IP address on the system. So we'll click on OK, and you'll notice it put there for the source IP address the local IP address of that DMZ server. Now, as that packet is going from the DMZ server out to the internet, we are not going to translate the destination address. And that's because Lois out on the internet has whatever IP address she appears as. We're not going to translate the destination going out to Lois. So those are all the considerations for the original packet from the server's perspective. Now, if all those criteria match up, how do we want to translate that packet? We want to translate that source address of the server at 10.2.2.1, its local IP, and we want to do a static IP address translation, and that translated address, we want to go ahead and use, oh dang. It would be really nice if there was an option right here to add another address object. And we could create a global address object that represents 192.168.1.251, which is the globally reachable address we want to assign it. But what we can do is we can just type in an IP address, 192.168.1.251, just like that. And that works too. And then here's the secret. If we want this translation to be able to work both directions, meaning whether server 1 sources a packet or if somebody out on the internet is trying to reach server 1 through its globally reachable address, we simply check this box saying bidirectional and poof, it's done. Well, it's almost done. We got to click on OK, and of course we'd also want to click on commit, which we'll do right now. And then we'll click on OK to confirm our commit. So that is on its way. Fantastic. Now that NAT's set up and this server has the global address of 192.168.1.251, we're now going to set up our security policy that permits, for example, Lois or any user on the internet, if they hit that IP address and they're asking for HTTP resources, for example, they want to connect to a web server, we want our security policy to say, absolutely yes, that's perfectly fine, which will then forward that traffic through the firewall to server 1 at its address of 10.2.2.1, and that translation will happen because of the NAT rule that we just implemented. So let's create a security policy that allows HTTP to that global address of .251. So to do that, we'll go to Policies, which is where we currently are, and on the left-hand side, we'll select Security. We want to create a new security rule, so we'll click on the Add icon to add a new security rule, and then we just follow the tabs. And let's call this Web Access to Server 1. And we can specify this as an inter-zone rule as well, because that's exactly what it is. It's going to be specifically for traffic sourced on the outside going to the DMZ. Regarding the source zone will be the outside, so we'll select that. And regarding source address, we don't know what IP addresses will be used by Lois and the thousands of other people that might be trying to access this web server, so we're going to leave the Any checkbox checked regarding source IP address. Next, we'll go to destination. The destination zone is where that server really lives. So we'll click on Add, and we'll specify DMZ as the zone where that web server lives. And its destination address, we are going to click on Add here. And here we're going to specify the global address, the address that the customers are actually trying to hit from the outside, as being the destination. So we don't yet have a server 1 global IP address object, but we do have this option of creating one. So if we wanted to create one now, we could, or we could just type in the address again, which is also fine. 192.168.1.251. That'll work as well. Next, in this rule, we want to identify that the service of HTTP is available for customers requesting that service or coming in on those ports. So to do that, we're going to go to service/URL category, and we're going to click on the Add button, and we're going to select service-HTTP, which implies TCP port 80 as part of this rule. And then we'll work our way right to Actions, and we are going to allow that, and we'll click on OK. And then we'll commit that as well. So we'll go ahead and click on OK. So from my management PC, or one of my computers out here on the 192.168.1 network, we should be able to go ahead from this PC, open up a browser to http://192.168.1.251, and based on the network address translation, that should lead over to server 1, and based on our security policy rule, HTTP should be permitted. So let's verify that works. So let's bring in a browser. Again, this computer is sitting out on the off the 192.168.1 subnet. And we'll go to http://192.168.1.251. Press enter. And survey says this is a very good sign. This is the login screen for the graphical user interface on that Cisco router. So the user we created was called admin. The password was capital NUGGET exclamation mark 23. That's the one we configured, and we'll press enter to log in. And there it is. This is the web page for that exact router right there. So that implies that our network address translation rule is working, and the security policy is allowing the HTTP traffic to go through. It's assessment check time. So take a moment, pause the music, read through all these questions, think about what the best answers to these questions are, and then when you're ready, click on resume, and we'll go through them together. All right, question number 1. Which VMnet inside of VMware Workstation in our lab topology that we've been building, which VMnet represents the 10.2.2 subnet? And if you said, Keith, I got this. That is VMnet 2. And that's important just to remember that if we want to add devices to that 10.2.2 network, whether it's in VMware Workstation or doing it through GNS3, that's our target for that 10.2.2 subnet. Question number 2. Why involve GNS3 at all for the web server? And one of the answers to that is it is so stinking easy. If you have GNS3 currently running and up and functional, adding a little router, putting a few lines of configuration in is really easy and you're up and running. Now, if you are really comfortable with some other operating system, maybe Linux or Windows, that has web services and you want to add that into VMware Workstation and associate it with VMnet 2, that's great as well. I just want to give additional options for people who wanted to make it as simple as possible. The next question, what, I suppose that should be which. All right, which 2 firewall elements allow DMZ server access? And I'm referring to the Palo Alto. What 2 elements do we need to configure on the Palo Alto to allow that access? And if you said to that one, network address translation and a security policy to allow the communications, those are the 2 that I was looking for. Good job. And finally, are you labbing this up or are you planning to? And my intention is for you, my friend, to absolutely practice everything you possibly can with hands-on. In this nugget, we discussed and demonstrated setting up DMZ services by leveraging network address translation and security policy rules. I'm glad you joined me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.